Hello, here in this video we're going to look at 1.5, graphing linear inequalities. Here's the why. We rarely have to be perfectly equal in life. Instead, there are various solutions to a problem. And inequalities relates back to that idea. We've covered this some in the past. Being on time. You don't have to enter the classroom exactly as that bell rings. You should really be there less than, before that bell rings. Paying a bill. You don't often have to have exact change. As long as you have that amount or more, you can pay a bill. Talked about winning in various sports. You often want to have more points than the other team. What we're going to do now, though, is take equations that aren't just in one variable, but take equations that have two variables. So in this case, we have T and C. So we have a delivery crew is going to load a truck with tables and chairs. The truck's weight limitations are represented by this inequality, to where we see here that each table contributes 200 units of weight, each chair contributes 60 pounds of weight, and the total amount of weight that the truck could have is 1,200 units of weight. So, what we're going to ultimately do in this section is graph and find all the possible solutions that would work, right? Because, one option would be don't put anything in the back of the truck and it won't be too heavy. But there's lots of combinations. You could do one table and one chair, two tables and one chair, and the amount of solutions for this there's lots of them. And making a graph will allow us to see all of the whole number combinations that satisfy this inequality at once. So that's what this section's all about, is it's allowing us to find multiple combinations or to see a picture of how many different options we have to choose from to still make something work. And it allows us to talk about it from two variables rather than what we were doing in 1.2, where we were only making a number line and solving them with one. Okay. So it says, explain how the solution set for 3x minus 4 equals 8 differs from the solution set of 3x minus 4 is greater than 8 and the solution set of 3x minus 4 is greater than or equal to 8. And what you'll notice is that this component's the same on all of them. But what's changing is that one of them is an equal sign, one of them is a less or greater than sign, and the other one is a greater than or equal to sign. So when we're looking at inequalities, here's the difference. An equals means the line itself is the only solutions. So if you're looking at an equation that we would have graphed, for y equals mx plus b, the points on the line are the solutions. If we have this greater than, though, we're going to see that that's a dotted line. And what the dotted line is going to mean is that the line doesn't count as solutions, right? But that greater than is going to tell us to shade above. So any points above the line are the solution. Because when we make inequalities, we're going to see that they are lines with shadings to encompass all the possibilities that work. Now, when we see a greater than or equal to, both the line itself and points above will work. Right? So the difference is that with equations, only the line matters. When you have an inequality without a line, so without that or equal to, only the shadings will matter. And if we have a line underneath the inequality, both the line and the shadings will matter. So here's what we have. A linear inequality is just like a line but it includes shading. Will ultimately be shading above or below the line. The boundary is the line itself, and it divides the solution region from the not solution region. And that line itself can be dotted or solid. The constraint is that part of the inequality, like the greater than or less than or greater than or equal to or less than or equal to. And it'll be what we use to check our answer. Used to check solutions. So let's give us a visual for this. Here's a graph. Now the graph for this inequality, and we'll practice on writing some of these, is going to be y is greater than or equal to, and then this one has a slope of negative 2x and a y-intercept of 2. And after we graph some of these, we would be able to write these equations no problem. And so for this, it says, the graph of the inequality involves a situation with a constraint. Explain how you know which points on the graph satisfy the constraint. So the shaded region tells us where our solutions are. So what I'm going to do is I'm going to pick a point that is not in the shaded region. I'm going to pick 0, 0, which is not a solution. And then I'm going to pick 1, 3. And what we'll see is if we plug in, x is 1, y is 3, into our situation. So for this first one, I'm plugging in 1 for x and 3 for y. That was just a random point I picked out of the shaded region. We get that 3 is greater than or equal to, and so to sort that out, it would be negative 2 plus 2, 0. We get a true solution. 3 is greater than or equal to 0. So any time you pick a point, I could have picked this point, could have picked this point, could have picked this point. Anytime you do that, you would get a true statement. The numbers would be different, but the constraint would be satisfied, that the number on the left would be greater than or equal to the number on the right. Now notice what happens if I pick a number that's not in the shaded region. When I simplify this, I get that 0 is greater than or equal to, and so that was a 0 plus 2, a 2. Notice that it's not true. 0 is not greater than or equal to 2. So we know a constraint is satisfied when we pick a spot from the shaded region, or if the line is filled in, I'm going to pick this point right here, which is exactly on the line. It's 1, 0. We get that 0 is greater than or equal to 0, and it's also true. If you pick a point on the line, you'll always get the same two numbers, but since the line is solid, there's a or equal to line underneath it, and that's what allows those to work. And that's why if that line would have been dotted, I cannot include points from the line, because 0 isn't greater than 0, but 0 is greater than or equal to 0. And as far as it goes for the shadings here, if the inequality is or equal to, then the line is solid. I always say if you see a line, you draw a line. If the inequalities are not equal to, so just less than or greater than, the line is dotted. If the inequality is greater than, we shade above the line. And if the inequality is less than, we shade below the line. And this is talking about, these guys right here are talking about y mx plus b. right? To where when we put this inequality here, if its y is greater than, we shade above. If its y is less than, we shade below. There's different strategies we can use if we're not in y equals mx plus b form. But that is, in general, some good ideas to help graph linear inequalities faster.